Now about lactam hydrolysis, we're going to use an acidic and a basic mechanism. And you can see the top one is going to follow the acidic pattern. And the first step, we'll have the H plus add to the C double bond O. That'll leave a positive charge on the C. Then we can have water come in the second step, attack the C plus. And we know that the proton will be transferred to the group that's the leaving group, and that was the group originally attached to the C double bond O, that's the N. So we'll transfer the proton there. Then the C double bond O can reform and release the amine part. Alright, so that'll give us the first one. Now let's look at the basic one. The OH negative will come in, attack the C double bond O, or attack the C from the C double bond O. Let's make that a little bit clearer. Negative charge moves up on the oxygen. Now the negative charge comes down, and then we get the negative charge on the N. Now the N negative will take a hydrogen off the carboxylic acid, and then in the second step we can have H plus added to the O negative, and we end up with our product. Now the reason we have to do this step is because what we've done is we've formed a carboxylic acid in a basic solution or a basic environment. So the N negative, which is going to be far less stable than this negative charge, will take a proton off the carboxylic acid, leaving us with the amine down here and the O negative up here, and then that can take the H plus. We do have an alternative though, which I'll show over here, and that is at this step, instead of having the N negative take the OH, we have an OH negative from the solution take the H. I don't think this is incredibly likely, but it could happen. It's more likely the N negative will take it just right there. And then we can add the H plus in the second step, enough to neutralize both of these, and then we end up with our product. So that's the second way of doing it, and both of these are fair enough ways of doing the mechanism for the basic hydrolysis of a lactam.